Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Have you ever wondered why it is so incredibly difficult to swat a common housefly? To your eyes, your hand is moving at a lightning-fast pace, yet to the fly, you are moving in slow motion, like a lumbering giant in a world of molasses. This isn't just a difference in size. It is a fundamental difference in how life perceives the four-dimensional fabric of our universe. Welcome to the world of the Minkowski butterfly, a concept that bridges the gap between complex entomology and the rigid mathematics of spacetime. In the early 20th century, mathematician Hermann Minkowski gave us the framework for what we now call Minkowski space, the mathematical setting in which Einstein's special relativity is most elegantly expressed. It combines the three dimensions of space with the fourth dimension of time into a single, four-dimensional manifold. While we humans tend to perceive time as a separate, flowing river, many insects have evolved to navigate this 4D landscape with a precision that mimics the very laws of relativistic physics. To understand the Minkowski butterfly, we first have to look at the concept of flicker fusion frequency. This is the speed at which an eye can process individual flashes of light before they blur into a continuous image. For humans, this happens at about 60 times per second. It is why a television screen looks like a smooth motion to us. However, for a dragonfly or a fast-flying butterfly, their flicker fusion frequency can be as high as 300 Hz. They aren't just seeing faster, they are sampling the fourth dimension, time, at a much higher resolution than we are. When a dragonfly chases its prey, it isn't just flying toward where the prey is now. It is performing a complex calculation across the 4D manifold. In physics, we use something called a light cone to describe the path that a flash of light, emanating from a single event, would take through spacetime. The dragonfly essentially operates within a predictive light cone. By processing visual data at such high speeds, it can map out the world line of its prey. A world line is the unique path an object takes as it moves through both space and time. While our brains struggle to predict where a moving ball will be if it changes direction suddenly, the dragonfly's nervous system is hardwired to intercept the world line of its target at a future coordinate. This is where the Minkowski aspect becomes truly fascinating. In Minkowski space, the distance between two events is not just a spatial measurement, but a spacetime interval. The insect's flight path is an optimization of this interval. They have evolved a biological version of the Lorentz transformation, allowing them to adjust their own frame of reference to match the velocity of their prey with near-instantaneous feedback. Their wings are not just flapping, they are vibrating sensors that detect changes in air pressure and light polarization, feeding data into a brain that functions more like a high-speed particle detector than a traditional processor. This 4D navigation is also visible in the way butterflies migrate. They don't just use landmarks, they use a time-compensated sun compass. They are aware of the sun's position relative to the time of day, effectively calculating their spatial orientation by accounting for the temporal dimension. They are traversing thousands of miles by maintaining a constant angle against a moving celestial body. A feat of 4D geometry that would require a sextant and a chronometer for a human navigator. The Minkowski butterfly is a metaphor for the ultimate efficiency of nature. By evolving to occupy a higher temporal resolution, these insects have effectively conquered the constraints of three-dimensional space. They move through the world as if they are seeing the past, present, and immediate future simultaneously. When we watch a butterfly flutter in what looks like a chaotic, random pattern, we are actually witnessing a highly sophisticated defensive maneuver designed to scramble the predictive spacetime calculations of its predators. It is creating a noise in the 4D grid, making its own world line impossible to track. This intersection of biology and four-dimensional physics reminds us that the universe is far more complex than our senses lead us to believe. We are limited by our biology to see the world in a specific way, but the tiny creatures in our gardens are living proof that spacetime can be navigated, sliced, and mastered by something as delicate as a wing made of chitin and light. For more incredible facts like this, don't forget to subscribe and turn on notifications.